This is solving by, or factoring by grouping. You begin by taking your 4-term polynomial and putting parentheses around 2 terms at a time. So parentheses here, parentheses here. Then you find the GCF of both sets of parentheses. So if I'm looking at 2AC plus AD, the GCF of 2AC plus AD is A. If you think about what your mouth is saying when you read that, 2AC plus AD, the thing that it is saying in both of these terms is A. So A is your GCF. So once you find your GCF, you factor it out of each term. And I wrote it underneath each term. And A cancels out. You write A here, you're left with 2C plus D. Then you come over and you do the same thing for the second set of parentheses. You find the GCF. So between 6 and 3, 3 can be factored out of both 6 and 3. B can be taken out of both 6BC and 3BD. Again, I'm saying B with each one of those. So I'm pulling B out. When I pull B out, I write it here. Or when I pull 3B out, I write it here. 6 divided by 3 is 2. The B's cancel. I have C. 3 divided by 3 is 1. We don't write our understood ones, remember? And the B's cancel, so it is just D that's left. All right, when I finish, when I've done that, when you're looking at this problem, in order to know whether or not you've done it correctly or whether you need to go back and look at it again, is what you have left right here in this set of parentheses should be identical. It should be the same thing. So I have 2C plus D, 2C plus D, I'm good. And the last step is just to group them. You write A plus 3B in one set of parentheses, and then you have 2C plus D in the next one. All right, let's try another problem. Same thing. You're going to put parentheses around 2 terms at a time, and then you're going to pull the GCF out of both of them. If you notice, XZ plus XW, X is what I'm saying, so I'm pulling X out. I'm going to divide by X with both of them. That leaves me with Z plus W. I'm going to go to the second set of parentheses and do the exact same thing. I can pull Y out of both of them. So when I get done and I factor it out, Z plus W is left. Now, Z plus W, I need to check and see if they're the same thing. They are. So I write Z plus W in this set of parentheses, and I take these two and write them here. X plus Y times Z plus W. Do not forget this step. I see students reach this step all the time and forget to go here. It's not finished until you put these two in a parentheses next to this one. All right, same exact thing, you're pulling the GCF out. Group them by 2, pull the GCF out. In 4K plus 12, I can only pull 4. So I put 4 here, I divide each term by 4. 12 divided by 4 gives me 3. 4K divided by 4 gives me K. I come over here, I have K squared plus 3K. Now, K is my GCF, not K squared. That's because there's only one common K in both of them. If I were to expand this, it would be like seeing K times K plus 3 times K. And the only thing that they have in common is 1K. This one does not have a second K. So I'm only pulling a K out. Then when I pull that K out, you'll see what's left, K plus 3. Now, just like before, I have to have the same thing here and here. And I do. I have K plus 3, and I finish by writing 4 plus K in parentheses times K plus 3. Now, you will see some textbooks, some standardized tests, some things always like to put the variable first. So this is the same thing as what you see above it. So K plus 4 times K plus 3 is identical to that. They've just taken these two and flipped them around. Okay. Now, notice here what's different. Everything I've done so far has had all pluses. This does not. There are minus signs right here. When that happens, when you factor out the GCF in the second set of parentheses, you're just gonna have a minus sign with that GCF. And it's gonna take care of everything. All right, so GCF here is 3x. Divide each term by 3x. 6 divided by 3 is 2. X cubed divided by x is x squared. 9 divided by 3 is 3, and the x's cancel. All right, come over, do the same thing except for when I factor this time, instead of writing plus 2, I'm going to write minus 2. And then I'm going to divide each term by negative 2. So negative 4x, negative 4 divided by negative 2 is positive 2. And then write the x squared. Negative 6 divided by negative 2 is positive 3. And if you see, they're the same thing like they ought to be. And then I group them and get 3x minus 2 times 2x squared plus 3. All right. I have another problem identical to that one that we just finished. So we've got plus, plus, minus, minus. That means my GCF over here is going to be negative. So I'm taking my GCF out. X cubed divided by x is x squared. And then we have xy squared. And so I'm pulling x out. All right, now. So I have x, and this is x squared plus y squared. And then minus y, not plus y. And so when we come over here, the y is what they have in common. And remember, you're going to pull the lowest exponent out. That's because I have 1 y in this term and 3 in this one. And the only thing they have in common is one of them. All right, so I'm pulling that out. So this is positive x squared plus y squared. In this parentheses, x minus y times x squared plus y squared. All right, this one is a bit different because sometimes when you put parentheses around the two terms, it doesn't work. So if I put parentheses here and here, there is no GCF in the first term. There is in the second term, but it doesn't help me to pull it out. So if I have z cubed minus 6, and I pull out the z in the second set, and I divide this by z, I get 2 minus 3z. This and this are not the same, it doesn't work. So when that happens, what you have to do is you have to rearrange the terms. Now, what I try to do is rearrange terms that have the same signs. So I need to either rearrange these two or rearrange these two. And it's trial and error to see which one will actually work. So I happen to, for this problem, to rearrange these. So I rewrote it, and I wrote z cubed minus 3z squared plus 2z minus 6. And then I pulled the GCF out. So between z cubed and z squared can come out. Now, I have 3 z's, and I have 2. So this time, they've got 2 in common. So I'm pulling out z squared. So z cubed divided by z squared is z. 3z squared divided by z squared, is negative 3. Then I'm taking out of this one 2, and that gives me z minus 3. And if you will notice, it works this time. So therefore, I write z minus 3 here and z squared plus 2 here. This is our last example. What happens here is this. When I go through and I solve this one, and I put my parentheses here, and I pull the GCF out, and I take 2x out, that leaves me with y. And this leaves me with 3. And I come over here and I pull 4, and you can see it in green. That's what I did first. So I divide by 4. That gives me 3 minus y. I want you to notice that these two parentheses are exactly the opposite. This is positive y, that's negative y. This is negative 3, that's positive 3. So they are exactly opposite. When that happens, all I have to do is change the sign of the 4 from a positive 4 to a negative 4. And that allows me to turn these around. Okay, it's like seeing 3 over 3 simplifies to be 1. 3 over negative 3 simplifies to be negative 1. You can still simplify them. They still have a GCF. It's just their answer is different. So when I came over and I pulled that 4 out, and it was exactly opposite of this one, that let me know all I needed to do was pull a negative sign out, and that takes care of this. I can then turn it all around. So now I have something that is the same. When I take negative 4 out of 12, instead of just positive 4, 12 divided by negative 4 now gives me a negative 3. And negative 4y divided by negative 4 gives me a positive y. And now you see they're exactly the same, positive y, negative 3. So it's more common to write it y minus 3, so then I group. Thank you.